Hi, this is Shorodip, and this video will be about finding the approximate factorial of a very large number. This is a short version of my earlier video, which was around 18 minutes long, and it packs the same content in um, in an efficient manner so that you'd be able to understand the same thing in a very short time. So let's start with a factorial. So, for example, we all know what a factorial is. It's basically um, for example, 10 factorial would be 10 into 9 into 8 into 7 into 6 into 5 into 4 all the way till 1. Um, 5 factorial, for example, would be 5 into 4 into 3 into 2 into 1. So it's pretty easy to calculate 5 factorial. I mean, you just multiply 5 with 4, 4 with 3, 3 with 2, 2 with 1, and it gives you a value of 120. 10 factorial is slightly more difficult. You need to probably use a calculator, and the answer would be 3628800. It's pretty easy to calculate the factorials of such small numbers. We just multiply. But what about factorials of very large numbers, for example, 10,000 factorials? So you would be multiplying 10,000 numbers, and the order would be around, of each number would be around 10,000. So 10,000 into 9,999, 9,998, that's pretty daunting even for a computer. So even computers will run out of memory. So I'll be showing you the idea of the tutorial. So first, what we would do is find the logarithm of the factorial. And then after finding the logarithm of the factorial, we would find the antilog of the factorial. So a logarithm has a very special property. It converts a multiplication into an addition problem. So log of, for example, 10 factorial would be log of the multiplication of these numbers. So the property we would be using is the log of a multiplication of various numbers would be the log of the individual numbers making up the multiplication. So log of 10 factorial would be log 10 plus log 9 plus log 8 all the way up to log 1. So what we're doing here is, instead of multiplying 10 with 9, 9 with 8, 8 with 7, 7 with 6, 5 with 4, 4 with 3, 3 with 2, 2 with 1, we're just bypassing that. And then um, we're just finding the logarithm of each separate number and then adding them up. So we're bypassing multiplication and just adding the logarithms of the numbers. And mind you, logarithms of numbers are much less than the original number. For example, log 10 is around 1, and 1 is much less than 10, as you can understand. So, so we don't need to calculate the value of 10 factorial itself to find out the value of log 10 factorial. We just have to find the log of the individual numbers and add them up. So I have listed a value of the logarithms of um, 10, 9, all the way up to 1. And you have to add all them up. So log 10 factorial would be all these values, like add these values. What you would get is 6.5591. So 10 factorial would be the anti-log of 6.5591, 10 to the power of 6.5591. So let's see, 6.5591 10 to the power, which is around 36,23264, 36,23264.175, which is pretty close to the actual number. At least the first three digits are the same. The actual value of 10 factorial is 3628800. So 10 factorial is 3628800. And the value we get here is 3623264.175. It actually depends on how accurate your logarithms are. So here in this case, I've truncated log 9 to just 4 digits. Log 9 is actually a pretty large number. So log 9 is around 0.954242509. It's a very large number. So unless you can, um, your accuracy would depend on the number of digits after the decimal point that you take in your calculation while adding the logarithms. So for instead, yeah, so instead of 0.9542, if I would have taken 9542425509 up to this, maybe my answer would have been more accurate. So your answer would depend on the accuracy of the logarithm that you're taking. So let's go to the logarithm of 10,000 factorial. So log of 10,000 factorial is basically log of the multiplication of all these numbers. So we just bypass multiplication and then do addition. So we add the log of 10,000, the log of 9,999. So see that log of 10,000 is a very small number, which is 4. Log of 9,999 is even less than 4. So how difficult is it um, to add 4 to a number less than 4, to a number lesser than that, all the way up to 0? It's pretty easy. Instead of multiplying these huge numbers, 10 to 10,000 into 9,999, just adding 4 to a number less than 4 to a number less than that. So it's a large computational advantage. You can just write a computer program to just add these small numbers. It's pretty easy. So the result I get by adding this is 3.565 into 10 to the power of 4. So the answer would be the antilog of 35659.454. So that would be 10 to the power of this 10 35659.45. So which is equal to 10 to the power of 0.4542. I mean the places after the decimal point into 10 to the power of 35659. So it's a huge number. It's a huge number. And we obviously couldn't have gotten that by just multiplying those numbers. I mean, it's impossible. So, so 10,000 factorial would be approximately equal to 2.846259 into 10 to the power of 35,659. So that's a huge number. That's a damn huge number. So this was the idea. Thanks. Thanks, like and share and subscribe if you like.